Steep approach. Steep approaches are mainly used where there are obstacles or noise constraints. This type of technique allows approaches into runways that otherwise would be unfeasible. Approaches over buildings, towers, or poles, or approaches into areas where noise levels have to be low, are many times steep approaches. Approaches where the final glide path is higher than 4.4 degrees are classified according to operational regulations as steep approaches. This classification implies that some special requisites associated to it must be satisfied, ranging from crew training to visual path guidance from the ground. For steep approaches with the ERJ, the maximum tailwind is 5 knots. Landing flaps must be 45 degrees. The autopilot minimum use height is 200 feet. The steep approach landing may be performed with an approach flight path angle up to 5.5 degrees. The operation cannot be initiated with one engine inoperative. The operation is not permitted if the steep approach mode is not armed. The steep approach mode is selected by means of the push buttons installed on the glare shield panel. When either push button is pressed, an internally preset mode of the EGPWS changes the references to appropriately sound the sync rate and pull up oral warnings. After the flaps are selected to 45 degrees during an approach, the steep white light illuminates on the steep approach push button, indicating that the steep approach mode is available. If the steep approach push button is pressed, the green light illuminates to indicate that the steep approach mode is engaged. Pressing the push button twice will cancel the operation. If the green light does not illuminate, the steep approach mode is not engaged, and the steep approach must not be performed. When either the flaps are retracted to a position other than 45 degrees or the airplane lands, the steep white light automatically extinguishes, indicating that the steep approach mode is no longer available. The push button also incorporates an amber light that illuminates to indicate that the steep approach mode has failed. In this case, the steep approach must not be performed. The steep approach can be performed either manually using raw data, with the autopilot engaged, or following flight director guidance. No steep approach should be initiated unless the prevailing conditions have been understood and the crew found that landing is acceptable without undue risk. Landing distances associated to steep approaches are often restrictive, so careful determination of the approach and landing speeds is paramount. The crew must be very aware of the missed approach procedure. Philosophically, all approaches should be treated as approaches followed by missed approaches, and landing should be treated as the alternate procedure. This idea may look simple at first, but in practice it is not always easy to have all pilots with their mind set on the missed approach whenever they do an approach. This mindset depends upon a good approach briefing, on the knowledge of the missed approach procedure, and on proper programming of the FMS. Let us follow along a steep approach sequence. On final, establish on the final glide path. After the landing gear is down and the flaps are at 45 degrees, the steep approach white light will be illuminated on the push button. Just press it to let the system know that you want the steep approach mode engaged. Check that the green light illuminates. An associated call-out is recommended. The aircraft must be fully stabilized on approach when it is 3 miles or 1,000 feet from touchdown, whichever happens first. A stabilized approach is so when speed is stable, flight path is stable, thrust is stable, and there are no more configuration changes. Your speed during a steep approach is the same VAPP for a normal ILS procedure, which is the VREF plus the wind correction. Remember that maximum speed correction is 50 knots. Due respect must be given to the primary control of the airspeed and rate of descent. Descent ratios during steep approaches are in the range of 1100 to 1200 feet per minute, as opposed to 700 to 800 feet per minute on a normal ILS approach. Aircraft pitch angles are consequently lower too. The rate of descent during the steep approach will be influenced by variation of the thrust setting. The steeper the approach, the less thrust is needed. But remember, approaches with idle thrust should be avoided. In this condition, idle thrust, the crew has little control over the aircraft if a quick thrust correction becomes necessary due to a downdraft or if the speed suddenly drops. When an engine is at idle, spooling it up to a high thrust condition takes far more time than when this engine is functioning above idle. The dynamics of a turbofan engine is such that the initial increase of thrust above idle must happen slowly, and only when a certain thrust is reached, the pace of increase can pick up. To cope with this delay in RPM acceleration, remember that the corrective thrust is proportional to the amount of sink rate which needs to be trimmed. Small amounts of sink rate will require smooth, gentle, and anticipatory corrections. Anticipate any need for more thrust and apply enough of it in good time. If you delay, you will need a lot more thrust. Similarly, if an excursion to high thrust has been necessary, don't leave thrust up for too long. Reduce thrust fairly soon, and you will fly in the stabilized target again. Make sure the airplane is properly trimmed during the approach. This maximizes the authority for the flare, or in the event of a missed approach. At approach minima, the pilot must make the decision whether to land or go around. In addition, the autopilot must be disengaged at approach minima. High sink rates near the ground must be avoided. Of course, steep approaches require higher than normal sink rates. But even so, if sink rates of more than 1500 feet per minute happen below 1000 feet, a missed approach must be initiated immediately. The steep approach will require a more consistent flare, which will result in a great variation of speed and rate of descent at touchdown. A flare initiated too early will cause the airplane to float, which will increase the landing distance. A flare too late will result in a hard landing. As the airplane approaches the touchdown point, thrust levers should be reduced so that they are at idle upon touchdown. Good flare-thrust coordination is essential. Flaring high and reducing the power to off quickly can cause the plane to settle abruptly. Keep the power on and don't let a high sink rate develop. Plan touchdown as close as possible to the 1000-foot point. Do not allow the airplane to float in ground effect. Particularly, the London City Airport has high-intensity lights installed on the runway to mark the latest touchdown point. Touching down further of this point requires a go-around to be carried out. After touchdown, immediately ease the nose wheel onto the runway. Then apply forward pressure on the control column and aileron into the wind. Use rudder pedals for directional control. Steering hand wheels should only be used at taxi speeds. Use proper braking techniques to cope with a short landing distance. The airplane should be stopped within the shortest possible distance, consistent with safety. Proper touchdown point is more important than a smooth, charming landing. If the landing weight is limited by runway length, the use of maximum brake effort is mandatory until it becomes obvious that there is enough remaining runway for the use of milder braking. Things to remember. A stable approach is a contributing factor to a successful flare and touchdown. Unstable approaches may result in difficult landings with unexpected sink rates, side loads, or bounce backs. However, as in any approach, for that matter, any uneasy feeling by the crew that something is not quite right, or the realization that in fact the approach is not going to be successful, should be immediately followed by a missed approach. Over-controlling thrust is a common problem among pilots, especially when they have little experience with a subject engine, or when the previous aircraft they had flown was a turboprop. Turbofan engines take some time to respond. Expecting them to respond faster than they are capable to leads to over-control. The trick is basically use smooth and small thrust changes, allowing the proper amount of time for the engines to respond. Sometimes the aircraft is brought to final, either because ATC vectored the aircraft this way, or because the crew did not properly manage the speed, while still at high speed, and the deceleration towards the target approach and reference speeds requires the full length of the approach all the way to the runway. This scenario is riskier than normal and should be avoided. In some cases, such as for example when there is turbulence and wind shear, a missed approach may be the best option. Don't get caught by any of these situations. Treat the go-around as a normal procedure. Always be prepared to go around. As an airmanship principle, the aircraft should be fully trimmed at all times during any approach. This is especially true when it comes to aircraft where the longitudinal trim is based on change of the stabilizer incidence, because in these cases a mistrimmed aircraft is also an aircraft with reduced primary longitudinal control, as opposed to aircraft with trimmed tabs, where the mistrimmed condition means higher control forces only. However, that does not mean that the trim controls can be used as primary controls. Primary controls are to always be used first, and trim controls are just controls to reduce force. Threshold crossing should be done at VREF unless turbulence or wind shear makes it unsafe. The published performance is based on threshold crossing at VREF and at a height of 50 feet. If a technique different from this is used, there will be an inconsistency between the actual performance and the published performance. What to do then when, for example, wind changes are present and VREF may be unsafe? One possibility is to dispatch the aircraft assuming no wind on arrival. If so, any headwind can be safely added to the threshold crossing speed. For example, suppose the aircraft was dispatched to a certain destination assuming that there would be no wind on arrival, and the limit landing weight was determined based on this assumption, and prior to approach the ATIS informs a surface steady headwind component of 10 knots. Those 10 knots can be added to the threshold crossing speed, and the calculated limit weight still holds valid. While flight maneuvers have become more comfortable, landings remain the only maneuver that calls for a particular flying skill. That's where you are leaving the air to gently hit a hard piece of ground after flying a required flight path under restricted track, speed, and rate of descent. However, there is a real sense of success after making a good landing, especially under some hard circumstances. With a proper understanding of the flying qualities of your plane, a reasonable measure of training, and development of your flying ability, handling a steep approach on the Embraer jet will be no problem.